Hey there, science explorers! Have you ever noticed how things around us are constantly changing? Ice melts, paper tears, wood burns. The world is full of fascinating transformations. In science, we call these changes physical and chemical. Get ready to dive in and discover the difference. Let's start with physical changes. These changes might seem dramatic, but don't be fooled. They only affect how something looks, feels, or exists in space, not its chemical makeup. Think of it like this. When you melt an ice cube, it changes from solid to liquid, but it's still water, right? Here's the cool part. Physical changes are usually reversible. This means that the substance involved can often return to its original state without any chemical alteration. For instance, when ice melts into water, it can be frozen back into ice. This is a classic example of a reversible physical change. Remember the melted ice cube? We can freeze it again to get ice. This cycle can be repeated multiple times without changing the chemical composition of the water. Tearing a piece of paper is another example of a physical change. The paper is still paper, even though its shape has changed. We might not be able to put the pieces back perfectly, but it's still paper. The material remains the same, demonstrating that no new substance has been formed. Now let's talk about the real showstoppers, chemical changes. These changes happen deep down at the molecular level, meaning the substance itself is transformed into something entirely new. Imagine burning a piece of wood. It turns into ash, smoke, and gases, completely different from the original wood. Section 5. Unmasking chemical changes. Chemical changes often come with telltale signs. You might see light or heat, smell something new, or notice a color change. Think about baking a cake. The batter changes color, gives off a delicious aroma, and becomes a yummy treat. Clear signs of a chemical change. Section 6. Physical versus chemical. What's the difference? Let's dive into the fascinating world of science to understand these changes. So, how can you tell if a change is physical or chemical? It's simpler than you might think. Ask yourself, did we make a new substance? For example, when you mix vinegar and baking soda, you get carbon dioxide gas. If the answer is yes, it's a chemical change. This means new substances are formed, like when wood burns to ash. If not, it's likely a physical change. Physical changes alter the form, but not the substance, like melting ice. Remember, physical changes are usually reversible, while chemical changes are not. This distinction helps us understand the world around us better. Section 7. Rust, a chemical change superstar. Ever wondered why iron rusts? It's a chemical change in action. When iron reacts with oxygen and water, it forms a new substance, iron oxide, which is what we call rust. Pretty neat, huh? Section 8. Wrapping it up, the two sides of change. In this section, we've explored the fascinating concepts of physical and chemical changes. There you have it, the exciting world of physical and chemical changes. These transformations are not just theoretical, they are part of our everyday lives. From melting ice to baking cakes, these processes illustrate how matter can change forms in various ways. These changes are happening all around us. By understanding the difference between physical and chemical changes, you can unlock the secrets of the amazing world of science. Physical changes involve a change in state or appearance, while chemical changes result in new substances being formed. Keep those thinking caps on, explorers. Continue to observe, question, and experiment. The world of science is vast and full of wonders waiting to be discovered.